What we're looking at here is the southeasternmost front of the 16th of March lava flow, and it extended a little bit further to the southeast here, or south really, originally, but when they made the berm behind us, they actually excavated a bit out of this one. They used the material to help build the protective walls. Now what we're looking at here is actually right in front of the lava, but it's quite lobe-based. So we have one lobe here, there's another lobe right there behind us, and then we have a lava suture zone in between them. And even though these are actually lobes, because they have a rubbly top and they got a rubbly base, you can see here, they inflated. And they were actually placed as separate lobes. And they, not only did they inflate, they inflated in phase. So that we can see the wedges that come out of here on the side of the lava. Those wedges are actually lateral protrusions from the inner core of the lobe, the liquid part of the lobe. As it was inflating and lifting up, they shot out laterally. And then you lift it more up, they shot more out laterally. So there's a time sequence in those wedges, what we sometimes refer to as lava rise sutures. They actually record, because they form at a different time during the emplacement and inflation, so they basically add a record of the material as it was from the beginning to the end of the lobe growth. So if you sample that, you get a nice time sequence through the time that it took to emplace the lobe. And when you do that, typically you actually see that there's a significant variation in especially the crystal cargo of the liquid lava. Now there's more features in here which are really interesting, and you can see that this is totally polymer jointed, and it's kind of not quite radial, but approaching radial kind of jointing, meaning that this was reaching sort of a round lobe with a cooling surface that approximated a sphere. You see it like this, and then they come like that. You can see it even better there, a bit radial. So it is almost like the lobe is a kind of tube-like thing moving forward within the rubble, and then it stops and then cool from all sides. And we can see also the cooling joints are reasonably well developed here, and cooling joint surfaces like this one here, you have chisel marks, and these basically record the growth of the joint. So when the joint is cooling, they basically unzip laterally like this. Okay, and so down here you will have the solid. The part that is already below the solidus temperature. Up here you will have the part that is actually above the liquidus temperature. And you build a stress in between those two, and then as the stress overcomes the strength of this particular zone, it snaps laterally, and then it moves up and you keep doing it and it snaps laterally again. So the growth, the way the joints are growing, and like this. But the net growth is that way, but they do it in a zigzag pattern.
So you mean the side wall of the column is actually coming in intervals effectively?
It's growing in
intervals.
The cooling joint is growing in intervals or
yes. Then I'm with you. That sounds very exciting actually. Oh, this is why we have all these lateral things at the side of the column.
This is why you get the chisel
marks. I see.
So it goes like. Yes.
Yeah.
And the key thing is, when it snaps, it doesn't snap like this. It actually snaps like that.
Yeah, exactly. So
and then you build up the stress again, and where it is brittle, that's where it's going to break, because the viscous part is stronger than the brittle part, and it stops and it goes. You build it up again, bang. Build it up again, bang. And realize that the temperature gradient here is probably over like 200 degrees. at the time when this is happening. So you get a liquidus temperature up here and a solidus temperature up below solidus temperature here.
But why is the difference so large?
Well, because that's the difference between liquids and solids in these lavas.
Yeah, but I mean, like
Because
within that scale.
Because the coolidges are growing from the sides inwards, and you get liquid lava in the middle. And this is the boundary between the colder outer skin and the liquid lava, and it isn't more than this while the joints are growing.
Yeah, okay, yes.
Stunning little outcrop here. So,
And then you have a lot of other interesting things. So we've got a basal vesicular zone, and you can see it also over there.
Yeah.
And then a less vesicular core, and then
Yes.
a upper vesicular.
Yeah, that's clear.
So bottom crust,
Yeah.
liquid core, upper crust.
Yeah. It's all here.
yeah, it's a classic sequence for lava.
Yes.
So,
Yeah.
And these are crusts that are forming on the lava during emplacement.
Yeah.
They're not formed after emplacement.
Yeah. Are there like any pipe vesicles?
Not well developed pipe vesicles in this lava, but we do see some interesting things down here. You can see these vesicles, you look closely at them, and like this one and like this one, which has been stretched out for a bit. You see there's a darker material right there,
yes, it's classy.
Yeah.
and that's the segregated material.
Oh, that's the
Yeah.
segregated stuff.
And that's actually, if you analyze that,
The same as
that's
the
1.6, factor 1.6 more enriched in incompatible element than the host.
The same here as well.
Yes.
Yeah.
And you can see it in here.
Oh, there.
But is it only
And
is
you
it
can
only
see
the
the-
thin margin, or
You can,
no? That's a bit more material there.
Sometimes it depends on. We'll get back to that later. But you see here, and all of this segregated materials is originating from the basal crust or crystallization of the basal crust, because this up here, while that at that time when this is forming,
This is still more.
this is liquid.
Yeah.
So, and you can see the segregated material in it, vesicular. This is clear evidence of the second boiling. So all of that stuff in here, and this is actually is incipient pipe vesicle. A lot of pipe vesicles do have segregated materials in it,
Yeah.
and this is actually
Yes.
trying to develop into a cylinder.
Yeah.
It's inclined, and if we would have had a little bit more time, it would have. And you can see this vesicle here is dome-shaped, flat bottom. That means that the segregated material is settling to the bottom. The bubbles and the gases accumulate to the top. You're separating those, and the gas is trying to rise further
Yeah.
by trying to form the dome.
Okay.
So these are classical segregation vesicles, the base of the sequence. And if you go and you look at it further up, so you can see them all over here. It's not easy to see from here, but it's also there. Let's go to the other one. My face up here. And here you can see it's very nice segregated material, and you can see it's flat base.
Yes.
And then it's filling in here, so that the liquid is settling in the lower part of the bubble, and the gas is accumulated towards the top.
Yeah. And this part is also like vesiculous
Yes.
on the bottom.
So
This is-
it's not fired fully, lost its bubbles.
Yeah.
The bubbles haven't collapsed completely.
Yeah.
And then you see segregated material in here as well. So plenty of the
Exactly what you see in the Precambrian basalts in Finland as well. Like you see this picture, of course it's filled with white secondary quartz and stuff like that, but this kind of
But if you like to come over here, we can just be careful with stepping. So we see the same thing here, and it's even more nicely radial jointed. You can see the segregated vesicles at the base, and you can see all the chisel marks in the core. But if I remember correctly, I already did this before. Yes. See the big vesicles up there?
Oh yeah, the fat ones there.
The same
This is pretty good. Yeah, this one here is great. Not sure yet how to sample this. but
That's what it is.
Oh, stunning.
That's
So,
this is
fallen
what
log
we,
here.
that's what we call mega vesicles. Well, we
Very
don't
good.
really want it in. We want it in situ, but
Yeah, of course we do, but we take this as well. Because look here, you're right, Jussi, there's more of the same stuff.
oh yeah.
Look at this, I mean, this is good to get out. Oops. Fantastic. I think we can spend some time here.
Yeah, there's plenty of that stuff
There's
here.
good stuff. Well, Thor, say goodbye. Thank you very much for your time.